Login accepted.
All right, so first, careers in cyber and offensive security with Jimmy.
All right, so starting off with careers in offensive security, a lot of people have the question of, is offensive security or hacking a real career choice? To answer that, it's yes. There's a lot of different ways you could use offensive security to help protect companies or organizations, some of which being penetration testing, red teaming, vulnerability research, bug bounty programs, and tool development. Starting off with pen testing and red teaming, a lot of people get these mixed up. Penetration testing concerns the technical aspects of offensive security, and that's it. So if you're penetration testing for a company, you're looking at if there's any vulnerabilities on the infrastructure or any ways you could get in. The difference between penetration testing and red teaming is red teaming covers a lot more than just the technical aspects. They're also looking at the incident responders team, incident response, and blue team's ability to detect their activity on a network. And they're also trying to be stealthy in their operations to try to emulate a real world threat. Oh, I'm bumping around today. But so that's the distinction that a lot of people mistake between pen testing and red teaming. There's also vulnerability research and bug bounties, which are alternative ways to research into vulnerabilities or exploits in software or certain applications. Bug bounty programs are a way that companies could community source their vulnerability findings. And the way bug bounty programs work is the company basically says, oh, try to penetration test our network. If you find anything, report it to us and we'll give you a reward. So this is a good way to be able to get ahead of the curve and ahead of the public for vulnerabilities. So if people want money or an incentive to try to penetration test a network to secure it, bug bounty is a good option. And there's also tool development for offensive security, which you could develop tools to help emulate a real world threat. Next slide.
Dylan, I believe you wanted to comment a little bit about penetration testing and red teaming, or?
Yeah, so just to add a little more onto what Jimmy was saying. So with pen testing, you're strictly focusing on, as he said, technical aspects. You want to get the most done in the quickest time possible to provide the most value to your client. So depending on the type of test, if it's a network test, you want to find as much within their network as possible. If it's an application test, you want to test that application as much as you can. And you want to be really efficient with your time. You have to essentially be really efficient when it comes to pen testing. Red teaming, or also referred to as like adversarial simulation or emulation, that's going to be a lot more objective based. So typically the client has something set out that they want you to do. Either it is, we want you to see, can you reach this particular database? Can you, I don't know, obtain all of our PII, for example, something along the lines of that. And the time frame for a red team can be a little different from a pen test, whereas pen test, you might have like a week, maybe 2 weeks, if you're lucky to complete the engagement. Red teaming, the engagements can go on for much longer. There have been some engagements, few weeks, some engagements are even up to the months of duration. And because with red team, you're testing a more collective side of security, not just the technical aspects, but the people behind it, that you have, that's why the time frame is going to be much larger in most cases. And because of this, you have more time to be more strategic with your moves. in particular not being detected, since that's one of the biggest aspects of being red team. Whereas in the pen test, you don't care how much noise you make, you can do all the things you want, fire off as many alerts on their security team, but they are typically under the knowledge that it is you who's doing that. So there's not going to be as many issues. Sometimes there still is. Whereas red teaming, if you fire off an alert, they're going to treat it as an actual threat, because for the most part, they won't know that it's an actual engagement happening until that engagement is finished and you submit the report.
Yeah.
Dylan, did you also want to respond to Kenneth's question in the chat?
Oh yeah, I just noticed that question. My bad. So does red team include pen testing? It does include pen testing as a concept where you will be trying to penetrate the network, and but it's not, the methodologies are very different, because a lot of pen test methodologies, in particular network pen test methodologies, involve essentially being loud, because you're trying to be efficient. You're trying to get the most done in the quickest time possible. Whereas in red teaming, you have to be a lot more selective with your actions. If you're loud, you'll get caught and burn the engagement and not provide as much value as you can for the client for that particular, or for what they particularly want. Oh yeah.
Dylan, is it also similar to a black box pen test?
So pen test will depend on the scope, right? So for a pen test, they might just let you in the network and see what you could do. Because if they make you take the time to go all the way external, all the way in, that might take too long. And once again, like the client spending a lot of money for you spending 3 days on their perimeter, and then you get no findings, right? So pen test, their scope is usually like somewhat restricted, but at the same time, like they give you what you need, like when typically. But if it's like an external engagement, then that's a lot of times pain and suffering, because external is generally hardened. Whereas with red teaming, generally you'll start all the way on the outside, and if there's no way for you to get in, a lot of times you have to be careful if you want to do like a pen test methodology, like exploiting a web application, because that could once again burn your engagement. So sometimes that's why in a lot of red team engagements, you'll opt for things such as phishing. And then, but let's just say, you spend a lot of time and you can't get in, then you contact point of contact, and you might be able to be in an internal sense.
I see. Thank you.
Okay, so moving into how we're different from the bad guys. So for people that use offensive security to help protect a company, they have to follow the consent of the company, laws and ethics, and also communicate their findings to the company, as Dylan previously mentioned. Next slide. So these are some things to keep in mind. You always need consensual testing. So not only do you need permission from the company, you also need to stay within the scope. A lot of times in engagements, there's a certain scope you need to kind of stay in. So it's only these subnets or these systems that you want to penetration test. And staying in the scope is really important, so that you still have that trust between the company you're penetration testing or red teaming, and yourself as the penetration tester. Also, communication is very important through responsible disclosure. Responsible disclosure is just disclosing your findings. For example, in a bug bounty program, you want to disclose what you find, what vulnerabilities you find, to the company, so that they have the step, they're a step ahead of the public, and they're more protected in that way. Next slide.
Yeah, 1 second.
So here are the do's and don'ts for pen testing and learning pen testing. So like all of you right now, some do's are self-studying, joining clubs, attending trainings like this, competitions, and generally things like that. Things that aren't just going to classes or attending school or anything like that. Because pen testing isn't widely taught in school, you're not going to learn too much from your classes, or you shouldn't expect to be learned something as niche as pen testing in your whatever class you take.
Yeah,
Next slide.
especially with pen testing being a very popular, or at least a career that's growing in popularity due to its ability to usually work remotely. You do have to get a step ahead, so you do have to continue studying, self-studying, especially since classes don't generally give you the skills that you actually need for an engagement.
Yep. So which learning materials are the best? So try HackMe and Hack the Box are two of the best resources I would recommend, but there's also good resources like Vulnhub that also provide learning materials. The difference between these different resources is Try HackMe provides a beginner-friendly platform, which kind of walks you through the steps of learning different concepts besides penetration testing as well as pen testing. So, so it's more easy to follow along with the steps. And if you're just trying to get your foot in the door, I would recommend Try HackMe more than the other platforms as well. There's also platforms like Vulnhub and Hack the Box, which are less hand-holdy in that you're basically just put into this environment or told to penetration test a box, and it's up to you to figure out what you need to do. With Hack the Box and Vulnhub, the learning curve is a little steeper, but it still is a really valuable resource to people that want to practice pen testing.
1 second. Yeah, I would also just know that with Try HackMe, because it's relatively hand-holdy, you'll eventually get to a point where you will need to branch out to one of the other two or one of the other resources. As in an engagement, you aren't going to really get that hand-holding. You're not going to get as much information given to you as some rooms in Try HackMe do.
Okay, so on to some of the popular certifications. These are some of the places you could go to look for certifications. The two most popular are OSCP by Offensive Security and CRTO by 0-Point Security. The OSCP stands for Offensive Security Certified Professional, and this is more of your pen testing certification, where you basically try to find as many vulnerabilities on an environment and write a report to submit at the end. 0-Point CRTO certification is one that tests you on your red teaming ability. So your ability to laterally move and use C2 frameworks. There are also other certifications from CyberMentor, Altered Security, and eLearn Security as well.
Yeah, and if Dylan would like to speak, Dylan has experience with both the OSCP and also CRTO, both of the top two ones here.
Yeah, so the OSCP, it's sort of like the industry standard right now. It is very, very pricey, not affordable to the average university student that's trying to be financially wise, but I still took it anyways. It covers like the core fundamentals just in a interesting way, which you will find out if you ever take the exam. It doesn't, from what I understand and from what I've seen, it's not unique in any of the material that it covers. It's just mostly covering everything in a general sense. It doesn't get too technical into any particular field of network pen testing. The CRTO focuses on more red team ops. So red team and network pen test methodologies, and more what's considered OPSEC or operation security. So trying to minimize the amount of detections that you might leave, or the amount of alerts that you might fire off on a network. As for the other ones, they're ones I have not taken, but they all have something going for their own, particularly the altered security ones. And eLearn security is probably the second biggest name, right next to offensive security / the OSCP. So if you want a certification for your resume, look towards the OSCP. If you want something more affordable and you want more like a guided course to sort of learn things, and looking into the other certifications, it's probably your best bet. Yeah, if you like letters, do eLearn security. Their acronyms are like 7 or 8 letters, and I'm like, what do you mean? You have the ECCPT XV2 something? So I'm like, that's crazy.
All right, so what is a virtual machine? A lot of you guys probably know what virtual machines are, but a virtual machine is basically a way to host another operating system within your host operating system. So say you're running Windows or Mac on your host, it's a way that you could run another Windows, Linux, or another OS inside of your host machine. Next slide. So this is usually done through a hypervisor, which is basically a dashboard to manage your virtual machines. Two of the popular ones are VirtualBox and VMware. So these hypervisors give you a really easy way to allocate resources to your virtual machine, like how much CPU you're taking up, or memory or RAM. And it gives you a way you could have multiple machines at once and kind of connect them together and play with your own little mini environment.
We're not going too in depth over what what different types of hypervisors are. They help manage the resources for the virtual machine. Yeah.
So why VMs? So VMs are a good way that you could basically have a whole network of computers without any risk. Say you're testing some outdated software or some misconfiguration. You don't want to leave your host vulnerable to those misconfigurations, but instead you want to put it in a lab environment. So especially if you mess something up, you could just revert or delete the virtual machine instead of having to re-image your host or whatever you're working on.
Yeah, virtual machines are incredibly useful for a lot of the operations that we do as a team, as they allow us to rapidly spin up environments to test out new tools or attacks that we're doing, and easily revert them back to their original snapshot, their original state, so that we can test other tools, other attacks, or even on the defensive side, see what artifacts we leave and can use to detect those said attacks.
Yeah, and in an actual professional setting, unlike what we did today, you do not want to test in prod. This is a client, unless you're actually they're putting you in a dev network or giving you a development for like application or in any sort of isolated environment, then that's more lenient. But if you're actually testing in a production environment, which does happen very often, you definitely do not want to test random things that you've never seen before. Like, I wonder what clicking this one delete button in the client's environment is going to do, and you end up dropping the whole database. Definitely don't want to be doing that. So when you're actually doing tests, it's really helpful to, if you're getting no leads or you need the information, to set up the environment that they're working with, trying to recreate to the best you can, and then performing your testing there before taking it to the actual client environment, so you don't explode everything.
Yeah. So kind of moving on from virtual machines, one Linux distribution or kind of like flavor of Linux is known as Kali Linux. So Kali provides the tools for penetration testers in a sort of dedicated workspace. So if you want to penetration test something, or you want to use your tools against it, Kali is a good way to just have everything you need there. And it's different than, say, like Windows or any other Linux, because all your tools are already there, and it's specifically made for penetration testing. Other distributions like Ubuntu or CentOS are kind of dedicated for other tasks, but Kali is your pen testing distribution.
There are alternatives that I know of, like Parrot, and then some people like to make their own custom OS. However, custom distribution, but Kali is the most well-known offensive Linux distribution.
So onto networking. So the basics of networking, it basically relies on the client-server model. So the client-server model revolves around making requests and receiving requests. So in this case, the client is making the request to the server, and the server takes in those requests and responds with information to the client. So if you move on to the next slide, this could be an example of the client server. So let's say a computer is hosting an Apache server or a web application on the Apache service, and you're trying to make requests to that computer. In this case, as the person making the requests, you're the client, and the Apache server is the server. There's also a distinction between outgoing connections and established connections. So the way that you get connected a lot of the times is the client basically sends like a packet to acknowledge the server. So the client says, "Oh, hey, are you there? Like, can you talk to me?" Right? After that initial outgoing connection is established, or after it's made, then the connection becomes established, and it basically provides a ongoing communication between the two computers. Established connections don't need to re-acknowledge each other to make sure the other one is listening. It's just assumed, oh, they have a connection, both are listening. So a little bit more about how these connections work. So ports are basically how services communicate on a network level. So each port has a service running. So let's say you have a web server which has HTTPS on it. So this web server would have a port open, which is port 443, to receive HTTPS requests going in. So for example, if you're a client, like in this example, 10.0045 is the client. If they want to make a request to the server, they would have to send it through port 443. In this example, the first outgoing request goes through port 443. And after that, the connection is established and the two computers are free to communicate as they want to communicate. An important thing to note here is that only the server needs to communicate through 443. The client knows what it's sending and what it expects to receive on any of the higher number of ports that aren't dedicated to a specific service. There's also the term listening. In this case, the server is listening for that initial outgoing connection to establish a working connection. In penetration testing, there's also the concept of shells. So shell is basically a malicious connection that attackers use to remotely access a terminal of another computer or the desktop of another computer. There's two types of shells. There's a reverse shell and there's also a bind shell. So for reverse shells, the attacker is acting like the server and the victim is acting like the client. So to establish a reverse shell, the client has to reach out and make an outgoing request to the attacker machine first. So the way that attackers do this is having some sort of payload or command execution on the victim machine so that they could set up a reverse shell listener through a specific port and they could catch the request coming into them. This is different from a bind shell. A bind shell has the victim machine acting like the server in this case, and the attacker machine acting as the client. So the attacker would send a outgoing connection first to the victim machine to establish the connection. Bind shells are less common than reverse shells, but are still used in penetration testing. Okay, so here's an example of a reverse shell. So down below where it has Kali, the Kali instance is listening on port 1274 for an incoming connection from the victim machine. So the as you can see, the top is the victim machine, and it's basically piping the input and output of the terminal to that Kali instance. So the Kali could catch the connection and have remote access to interface with the victim machine. Okay, so on to firewalls. So firewalls are basically a way of managing what ports are open and what ports are closed. They're a good way to kind of lower your attack surface and know what ports are what ports could communicate to and from your network or your host. So for firewalls, there's two types of firewalls. There's host-based firewalls and there's network-based firewalls. Host-based firewalls just regulate the traffic going through your host, so your local host. This could be through Windows Firewall or UFW if you're familiar with Linux. There's also network-based firewalls, which regulate network traffic going through the network. So if you have a firewall that closes off connection to a certain port that's network-based, then none of the hosts in the network could access that port or talk through that port. This is a simple example of how some firewall communication could work. So in the top image, this is on the leftmost computer is the client reaching a web server. So in this case, the web server needs to have a database to hold the information. And you wouldn't want the database accessible to everyone. So you might want to put a firewall or something in between that so that the web server is able to access the database, but nothing else. So any attempts to access the database through the web server, it goes through. But as you could see, if an attacker is trying to access the database, it gets blocked from the firewall.
All right, and so now we'll be talking about some pen testing fundamentals. So on the slide, we can see a general cyber kill chain going from reconnaissance to exfiltration of the data or maybe credentials you need for lateral movement. We won't go in depth into this one in particular because on the next slide, we have a simplified kill chain going from reconnaissance to lateral movement. With reconnaissance, you are looking for any information that you can use that may help you gain initial access. With exploitation, you're trying to use the information you found to get initial access onto the network, onto your client's network. Then you get to the post-exploitation phase where you are doing steps 1 and 2 while having initial access on their machine and also looking for anything else that might be of interest, like credentials or any valuable and sensitive information that you can eventually use for lateral movement. So let's start with reconnaissance. Reconnaissance can basically be broken down into two different types of reconnaissance, that being passive reconnaissance and active reconnaissance. With passive reconnaissance, you aren't really leaving a footprint that your client would be able to tell that you're actually looking for them, that you're actually looking at their infrastructure. And passive reconnaissance is mostly dominated via open source intelligence gathering, or OSINT. And then with active reconnaissance, you are more actively probing their environment, so they know that you are actually looking at them and that you are leaving a digital footprint that they may be able to find and then link to you. So what exactly do we look for with OSINT? Well, it's a lot, because it's anything that we can realistically use to gain that initial access, either through something like phishing or via an exploit. So say, for example, you find some phone numbers or an email address, or you learn their culture and time zone. Combining all of those together, you might be able to start a successful phishing campaign to gain your initial access that way. Or if you instead find information about their APIs or whatever software they're using, and you so happen to get something like a version number, you may be able to find an exploit for said service. And down at the bottom right, we have a tool that gives you that is a tree of a bunch of different tools for every one of these categories. You can click through it and find a tool that may help you discover someone's IP address from a domain name, or search for their username on a social media website.
Keep in mind, weaponizing the previous information from OSINT for a phishing campaign is only possible if phishing is in scope. If it's not in scope, you definitely don't want to do that. So if you're on a phishing engagement or they're just putting it in scope, and feel free to do so. You'd never want to go out of scope when it comes to this sort of stuff, because then it's illegal, and that's never fun. When it comes to like trying to weaponize stuff for exploitation, you can't look more of that phishing stuff, because phishing is not going to be in scope. That technical information you can find from scraping the web, whether it be like finding information about API or service versions, that's going to be more generally useful. So there's that.
Yeah, you don't want to go out of scope. The whole point of this is to help them out, and if you go out of scope, you aren't really helping out your client. So we'll be covering some of the OSINT that we used for the competition, that we found useful for the competition, and thus you might find useful during the boot camps and, of course, during the tryouts. We're starting off with Google Dorking. Google Dorking is an incredibly effective tool if you know how to use it for not only offensive means, but it's also very useful for just general use case, as you'll be able to refine your searches to whatever you are looking for exactly. Some of these are listed to the left. There are a bunch more that you can find from the resources to the right. We'll just go over a couple of them here. So site will show you links. Will only show you links based off of the site that you put. So if you put something like site github.com, you'll only find GitHub links for your Google search. Next is file type, similar to site, but instead it will show you only that specific file type. So if you search for file type PDF, you'll find a bunch of links, all of them being PDF files. Plus or minus, add or remove that specific keyword from your searches. So if you do something like minus YouTube, it will remove the phrase YouTube from your searches, and you will only find links that contain text that do not include YouTube. I kind of talked a bit poorly by using YouTube as the keyword to remove, but it will also, you don't have to use a specific site. You can use any word like -code and you won't find anything that contains code. Or is just an operator. It allows you to combine all of these things together. We'll see an example of that later on the next slide with quoted text. And with quoted text, you're able to find exact string matches, which is very useful if you were trying to find exactly what you were looking for. Comp, did you get shunned for searching too much? Would someone like to answer that question? Perfect. So as I stated before, wrong slideshow. There we go. As I stated before, we did in fact use Google Dorking in order to actually find stuff relating to the competition. In this case, our client was a company called The Cozy Croissant. And here we are looking for anything that relates to their company via the use of exact string matches. And in this case, because we want to look for things that include spaces and without spaces, we're able to combine the exact string matches using the OR operator. And in this case, we found a very useful LinkedIn link that contained some information that was relevant to the client. Next, we have IP addresses. IP addresses is a relatively broad topic here because there's a lot of things you can do relating to them. For example, you could do a whois to figure out who exactly owns this domain, as long as it's not redacted for privacy. You can look for where an IP address is located, generally speaking, with VDNS IP locations. And then you can try to figure out an IP from a host name using a reverse IP lookup. ViewDNS.info also contains a bunch of other tools, not just there, but these are the ones that we've listed here so far. And we did again use IP address OSINTing. In this case, we're trying to confirm whether or not a site that we found called TCC Hotel CCTV, a closed circuit television, we're trying to find out if that was indeed actually owned by our client, thus confirming the scope, because again, you don't want to go out of scope. And by checking the whois, we were able to confirm that yes, it was indeed a site owned by our client, the Cozy Croissant, registered by Jamie Jackson. Next, we have subdomains.
Yeah, so subdomains are essentially going to be applications that could be hosted on the same server, which is going to give it like the same IP address, or it could be, but it has a different host name. That's why it's called subdomain. It's like that extra string of text that you can see that's attached to the top level domain. Sometimes it can be hosted on completely different servers, so there's that. As you can see on the picture over here, I'm using a tool called Subdomain. Well, I'd argue it's not as much active recon since you can make the argument for both, but you're still using what's available online at without actually tying yourself into being the one doing the scan. You're using like a public tool to scan the public internet for it. But regardless of that, you can see over on the picture on the right, cozycroissant.com. That's a top level domain that we're putting in, trying to see all the subdomains for it. And then it's able to find a VDI and warehouse subdomain, which both contain the same IP address. So they're still being hosted on the same server. And this could be helpful for providing a look into an additional attack surface, if that's assuming that's going to be its scope. You want to see what's completely external. And sometimes this can help you for your OSINT, because if you find these additional subdomains available, let's just say one of them is an AWS bucket, which is a service that people use to store a lot of files, and it's a publicly accessible bucket. Now you can scrape some interesting information that you might have not found from Google Dorking. In particular, if you're doing a specific OSINT engagement which does exist, then this is going to be something you definitely want to be looking into. Next slide, please. As for these search engines, I'm not talking about like Google and Bing. I'm talking about something more along the lines of something called Census or Shodan in this picture. I'm particularly using Shodan. So you can essentially put in a IP address or a host name. I believe Shodan only takes IP addresses, though. Could be wrong on that one. And what it does is it's going to essentially do like a scan on it. It's going to scan what's the ports are available, similar to Nmap, which we will be getting into in a bit. The difference is since this is checking publicly accessible infrastructure and you're using like a tool that's public. I mean, it is a bit of a, you can argue it's a gray area, but it's also like commonly accepted. Yeah, so there's a free Shodan version. I don't have the paid version. I don't know if there's a university discount or a university situation going on. I've never bothered to check personally. Could be a possibility because these services tend a lot of cybersecurity resources tend to be more lenient towards educational emails. But yeah, so you could toss some stuff in and get some scans done essentially. So you can see over here, I'm getting the IP address from earlier from the cozycroissant.com, and it's, or was it Le Bon Bon? I don't remember. The names are similar. But regardless, I'm getting that IP, tossing in, showed and seeing it what it can find. It's finding 80 and 443, which are web-based ports, and 9009. Didn't bother to check what that was. You can see it's doing some fingerprinting on the ports on the bottom right. In this case, it's getting the showing me what the result of a HTTP request, in this case a GET request, that is sent to it. And on the left we have some, as it says, general information. There would be more if we could scroll down, but you can run the scan yourself.
And then now we have Nmap. Nmap is a very powerful tool, a network mapper that'll show you the open ports on an IP that you choose, or the devices on a subnet of your choice. There are a bunch of different flags that you can use for Nmap. However, some of the useful ones we have are listed here on the left. TACP is to specify a port or a list of ports. You can specify a list via a dash, or you can specify individual ports as a group using commas, or you can specify all ports using TACP TAC. We also have SV, which is a version checker. It'll attempt to enumerate the service and also try to give you the service number. Unfortunately, this scan to the right doesn't have it, but we will see one later on. Next is SC, which will run the scripts of your choice. If you do not specify any scripts using the TAC script flag, then it will just run a bunch of the default scripts that it has set. And then finally, minrate allows you to set the minimum rate that Nmap sends packets, the higher being faster in milliseconds. It is incredibly useful when you are trying to scan a large network. You do have to be aware that by sending more packets, you have a higher chance of there being a false positive or an error, as the packets may not actually be received by the server, or Nmap may fail to actually send the packet. So here's the SV scan that we were talking about before. We're doing a version scan, and we find that on this host 10.10.10.189, we can see a pro FTPD server up. And then by finding out the version number, we can actually search that up and find an exploit through Google. Once we finish reconnaissance, we can use the information that we learned to do some exploitation. Here we have some useful tools for exploitation, the first one being the Metasploit framework. It is a very powerful exploitation framework that contains a bunch of tools to help you exploit a client's infrastructure, and also helps you with post-exploitation with the interpreter command and control. You can also do payload generation with MSF Venom in case you were trying to develop your own tool that may load that payload stealthily. Then we also have ExploitDB, which is a database that contains a bunch of different exploits for both exploitation and post-exploitation. However, you do have to be aware that sometimes the exploits are not verified, which means they might not actually work. They might be proof of concepts that don't actually have any code. They might contain malicious code. So you do have to be aware if you're running it on a client's environment. And you also may have to actually put in more work, as maybe the payload isn't completely fitted for your target, and so you have to modify the payload to actually work. And so here we can see someone using Meterpreter, or not Meterpreter, they're using the Metasploit framework in order to run a .NET new cookie deserialization remote code execution. We can tell that that's the payload since it's highlighted in red. We can see that they're setting the different options necessary at the very top, running it in the center. And then finally, we can see the Meterpreter C2 in action. Sorry about that. We can see that Meterpreter also contains useful post-exploitation stuff with Git system, which attempts to use multiple different techniques to elevate to system or root. Next, we have ExploitDB. If you noticed before, when we did the original Google search for ProFTPD, the link was an ExploitDB link. And here is that said ExploitDB link. We can take this payload, copy it, modify it, and then run it. Modify it if necessary, and then run it targeting the target device. Sorry if I'm rushing through these, because we are, again, on a time limit. Fun. Finally, post-exploitation. Or not finally, because there is technically lateral movement, but post-exploitation is, again, using both steps 1 and 2, again, to try to figure out more exploits, find out more credentials, but this time you're actually on their device, on the corporate network, or at least on something owned by your client. In this case, reconnaissance can be used to attempt for more post-exploitation, or it can be used to try to find sensitive information or credentials that you could use maybe for lateral movement, or to inform your client that, hey, we were able to get this, you probably want to fix it. Privilege escalation is used in case you're trying to find even more stuff, but it's locked behind different privileges, say administrator or root, depending on what type of operating system you're on. And then for looting, you're trying to find sensitive files, credentials, etc. For specific things like Social Security, you don't actually want to take it per se, because that would be very unethical and not legal, but you do want to inform your client about it. Here are a bunch of different ways for post-exploitation for both Linux and Windows operating systems. As you can see, they differ since both have their own quirks to them. And while we won't go over it today, we will be going over some of these during their respective weeks. And finally, lateral movement. For lateral movement, you can pivot using the credentials you find during post-exploitation, or maybe even the initial reconnaissance phase, with looted or reused credentials. And then further, for lateral movement, we have tunneling, which can be used to find things that are hidden from normal external view. So with tunneling, the slide's a bit messy, but I can explain it and it'll make much more sense. We have the same firewall example from before, but this time at the very bottom, we can see that a threat actor, or in this case, an ethical hacker, ethical pen tester, us, is trying to access that internal database, but we can't because the firewall is blocking us from accessing it directly. Also, interestingly, the database cannot actually communicate outwards with anyone except for that middle intermediate web server. So what if we tried to flow our traffic through that web server to access the database, since it is indeed something that can actually talk to it? We have multiple different ways of actually doing this. So first we have reverse port forwarding. So we compromised that middle, say we compromised that middle web server. What if we have one of its ports forward its data to one of our ports? By doing that, we can have the internal database send information to that port, and then it will be sent to us instead. We can also have it send out a connection and have that connection forwarded to our own port as well. We have multiple tools to do this: Chisel, SSH, or a C2 of choice. So in this case, we'll just be going over a quick diagram example. So we compromise that internal web server and have it forward its 1273 to our own machine. In this case, for simplicity, we'll have it forward it to our own 1273. We'll run a listener on that 1273 because we're planning on sending a reverse shell to said port. So now, through that web server, we want to communicate with that database. What if that database is running something like Postgres? Funny thing about Postgres, it is an intended feature that it can. An intended feature of Postgres is the ability to run commands. If you are a super user or someone's misconfigured permissions. So what if we reverse port forward that port 5432 to our own machine, interact with that database, and have it run a reverse shell? We can have that reverse shell be sent to the intermediary web server onto that 1273, and that 1273 will forward to our own 1273, which we set up a listener before. And now we have a reverse shell flowing through the firewall to the web server to us. Next, we have proxying traffic. Instead of reverse port forwarding a bunch of different ports, what if we just want to proxy our traffic through that web server, have it flow through it so that we can actually interact with that database directly? We can actually do this using a bunch of different tools. Again, Chisel. In this case, we have also Logolo MG, a command and control of choice. And to interact with it, if it's a SOX proxy, we can use proxy chains. Logolo itself isn't necessarily a SOX proxy. It works on a similar way via a ton interface, but technically it's not a SOX proxy. Anyways, we'll be talking about SOX proxies. It's a proxy that establishes a TCP connection with the destination so that we can actually communicate to it as if we're communicating to it directly. And so what we need to do is we need to compromise that web server and have it be our proxy agent. And then we also need, on our own machine, to start up a proxy server. We connect the agent to our proxy server, and now we can proxy our traffic from our server to through the web server to the database. And it can flow through the firewall as seen with that gray line. And now, by interacting with that SOX proxy, say with a tool like proxy chains, we can actually proxy our traffic between the machine, between the database and our own host through the web server. And now the lab. So with the lab, if you've already done this before, you'll be familiar with this. We're going to be doing Bandit. It's going to be part of the homework. The goal this time is to get to level 20, but the homework goes up to the homework goes up to level 33 because Bandit goes up to level 33. So your goal is to finish it and write down the approach on how you actually solved each problem or each level. And you should probably take notes because it's for the homework.